Hello, welcome to video number 76. This video is about factoring monic trinomials. So the secret is find the right two numbers to make this multiply to the given trinomial. Okay, so let's see how to do that. All right, first off, we have to be able to tell what a monic polynomial is. This factoring model is for monic polynomials, and we'll discuss ones that are non-monic later. So a monic polynomial is one whose leading coefficient is 1. The leading coefficient is the coefficient of the highest order term. So this 13 is a constant term. Minus 9x has x to the first power in it, and 2x squared has the highest exponent. So this is the leading coefficient 2. If it's any number other than 1, it's non-monic, which means it's not monic. Okay, so this one is not a monic polynomial. On this one, we see the x squared term is first. It's the leading term. The leading coefficient, we don't see a number, so we can assume it's 1. So this is an example of a monic polynomial. The leading coefficient of the highest order term is 1. Okay, this one is monic also. The highest order term is x squared, and the coefficient here is 1. So that's a monic. Okay, look down here. Leading coefficient is 6. Remember, a coefficient is a number that multiplies the variables. Okay, so 6 is the leading coefficient, and so this is non-monic. So this one's nope. And same with here, the leading coefficient is 4. So this is a non-monic also. All right, so again, we're going to learn two factoring methods. We're learning a factoring method for monics first. It's a little bit easier. Then we'll deal with factoring non-monics later. Okay, so we want to see if these following statements are true or false. We want them to be true for all values of x. That means they're equivalent. Any value of x I put in this left-hand side will give me the same thing as if I put that value of x into the right-hand side. What I really want you to see is that when it's a monic trinomial, these are all monic, that this number here that multiplies x is the sum of these two numbers. It's supposed to be the sum. And this right here would be the product. So in order for this to be true, 7 must be the sum of the numbers, 6 must be the product. And we can tell right away that's not true. 3 times 2 is 6, and 3 plus 2 is 5, which is not 7. So I know right away this is false. But let's multiply it out and see that it's false. So I'm going to use the everything with everything method. When I do x times x, we get x squared, plus I'm going to do x times 2, which is 2x, plus we get 3 times x, which is 3x, and 3 times 2, which is 6. And we see that these two terms combine to make 5x, x squared plus 5x plus 6. So I see that this middle number is the sum of these two numbers, and this number here is the product of the two numbers, but it's not what we started with. So this one is false. Okay? All right, so what I get when I multiply it out is not equal to the original. Okay, let's try this one. I'm going to multiply it out. X times x is x squared. X times minus 5 is minus 5x. Minus 2 times x is minus 2x, and minus 2 times minus 5 is plus 10. And so when I combine the like terms, I get x squared minus 7x plus 10, which is what we started with. So this one is true. Okay, and then take a look. How could I have known it's true? Because negative 7 is the sum of these two numbers, and positive 10 is the product of those two numbers. So I could have told ahead of time. All right, let's check this one out. Let's multiply. X times x is x squared. X times 5 is plus 5x. Negative 9 times x is minus 9x. And negative 9 times 5 is minus 45. When I combine like terms, I get x squared minus 4x minus 45, which is what I started with. So this statement is true. These two are equivalent. Now, again, look that negative 4 is equal to negative 9 plus 5. That is the sum of the two numbers. And negative 45 is negative 9 times 5, which is the product. Okay, this one. Let's take a look at the sum and product and see if we can tell ahead of time if it's going to work. So the sum of the numbers should be 3. 9 plus negative 2 is not 3. So I know already this one is false. But just to check, see how it works, let's multiply it. X times x is x squared. X times minus 2 is minus 2x. 9 times x is 9x. And 9 times negative 2 is negative 18. And so we get x squared plus 7x minus 18. It doesn't quite work. It gets the negative 18 right, but it doesn't get the x term right. Okay, so we were right. It's false. Okay, this is actually our last slide of examples. We're going to go ahead and factor these. These are all monic. Okay, since they're monic, I can kind of start off with this. I can write this as x, then I'm going to add or subtract something, and then I'm going to have another binomial with x like this. I got to figure out what to put in these two slots right here. What numbers do we need? Well, to make this work, we need two numbers whose sum is 16 and whose product is 15. So now we kind of think, what multiplies to 15? 3 and 5, but 3 plus 5 is not 16. 15 and 1. 15 and 1 works because 15 plus 1 is 16, and 15 times 1 is 15. So this would work out. 15 plus 1. Okay. Now, here, we need two numbers whose sum is 12 and whose product is 20. So I'll get this started. That's what it's going to look like when it's factored. All right, so what multiplies to 20? By the way, since this is a positive number, I know that both of these have to be positive or both have to be negative. In order to get a product who's positive, you either need two positives or two negatives. But since they add up to a positive, I know I'm looking for two positive numbers. All right, so I need two positive numbers that add to 12, multiply to 20. 4 and 5 doesn't work because it doesn't add to 12, but 10 and 2 works. So we can do plus 10 and plus 2. Done. This, by the way, is kind of called the trial and error method. I'm just kind of trying possibilities. All right, and we'll learn kind of a very powerful method in class to find the two numbers we need. All right, so here we need two numbers who sum to 4 and multiply to negative 12. Since the product is negative, one number has to be negative, one number has to be positive. Okay, so we start trying things like 3 and 4, like negative 3 and 4, or 4 and negative 3. Neither of those add up to 4. We could try maybe 6 and 2. Actually, if we try 6 and negative 2, I think that works. 6 times negative 2 is negative 12. 6 plus negative 2 is 4. So if we're kind of factoring by trial and error, we have to be patient. It takes a little while to kind of try the possibilities and come up with the right one. So you just kind of have to expect to try a few things. So it ends up being x plus 6 and x minus 2. All right, last example. Two numbers that add to negative 7 multiply to 10. So since this is positive, the product is positive, either both numbers are positive or both numbers are negative. But since we see that they have to add up to a negative, both of them have to be negative. Okay, so here we go. So we got to think of two negative numbers that multiply to 10 and add to negative 7. Well, negative 2 and negative 5 would work. Negative 2 times negative 5 is positive 10. Negative 2 plus negative 5 is negative 7, so we have a winner. Negative 2, negative 5. And sure enough, if you multiplied this out, it would equal that. All right, so this is a trial and error method in class. If you need it, we're going to learn a very powerful tool to find the right two numbers whose sum and product is what we want them to be. Okay, so here we go. For the journal assignment, please explain why these statements are true or false. And then for problem number 2, go ahead and factor these two trinomials. Good luck.